over to the next speaker. Let's pass over to the next speaker. This is our young but very promising researcher, Associate Professor Andrey Nikishin, Kaliningrad State Technical University. His report is called Review of Renewable Project for Baltic Region Sustainable Development. Dear Mr. Nikishin, the floor is yours.
So I will give a short overview of renewable projects for Baltic Region Sustainable Development. Mainly, I will speak about the wind projects, a little bit about the solar projects, which are not so developed. And this is the most developed renewable solutions in energy sector these days. They have some problems, such as low pure capacity factor. The production is difficult to predict, and they are not very reliable in terms of continuous 24/7 production, at least for solar photovoltaic systems. But they are really popular now, and why so, and why we expect them to increase their share in total electricity production in the future. The main idea of such sources, of this alternative renewable energy projects, is to reduce CO2 emissions and mitigate climate change. So I think everybody's seen such kind of prognosis, and it's very well known that we expect the decrease in traditional sources share and increase in the renewables. For the moment, we actually burn coal, natural gas and oil for electricity production, and this part gives us about 25% of total greenhouse gas emissions. So it's a pretty big sector, I would say. And despite that, more than 1/3 of global electricity comes from low carbon sources, such as nuclear, hydropower, wind, solar, and other renewables. Most of the primary energy, 85%, still comes from the fossil fuels. And producing more and more energy from the renewables each year, we still continue to burn more fossil fuels. And we expect that electricity demand will increase by more than 40% in the next 20 years. And this will require construction of many new generation capacities and facilities. And in this case, we have an opportunity to construct it in a way to limit greenhouse gases emissions. So this is the way for the future developments, as Mandalorian could say. And this also works for our region, for Baltic Sea countries. If we look closer, we see this significant difference in greenhouse gases emissions in different countries in energy sector per capita. And the leaders with the low emissions is Sweden and Lithuania, and outsiders, so to say, is Estonia and Russia. And if we talk about the total production of greenhouse gases, the biggest part comes from Germany and Poland, just because they're very big countries, so to say. And there is a big difference in average emissions from different type of electricity production technologies. So you see that if you use coal or oil, with the same amounts of electricity, you will produce much more greenhouse gases. And as a result, such difference in production of greenhouse gases can be described in different types of share of different sources in the total production of electrical energy in each country. So countries with high renewables production has low greenhouse gases emissions. For example, in Lithuania, it mainly comes from low carbon sources. As for Estonia, it mainly comes from oil shale and oil sands burned, so high emissions. If we build a heat map, kind of heat map for different types of electrical sources, so we see similar picture. If we compare leaders and outsiders, and we take into account that countries have similar weather and solar irradiation conditions in the region, we can predict that there is still a big potential for renewable development in some countries in Baltic Sea region, especially wind and solar. And it looks like a promising, sustainable future for the region, so to say. So the first and I think the biggest part is the wind power production. And if we talk about the wind power production, there are two big options, two potentials, so to say. This is the onshore and offshore production. Main advantages and disadvantages of both technologies are very well known. I will just mention a few of them. The advantages of onshore, that's it's relatively cheap, and we can install these wind turbines easily because it's very quick, and we have connection points in the energy system which are normally somewhere nearby, so our costs for the connection is also low. Disadvantages is that it's eyesore on the landscape. People don't like to see it anymore, and the load factor will depend on the place of installation, and in case we have development of the area, it will decrease the amount of energy we can get from the same place. And also the noise pollution is one important thing to take into account. For offshore applications, I personally think it's the future, because the wind turbines itself and wind farms could have much bigger capacity, allowing more energy collection, and there is no physical restriction like hills or buildings which could block the wind flow, and we can use a much bigger area for the production. We also have a low negative impact on the environment, but we should take into account the fishing areas, the migration ways for the birds and sea mammals and so on. Or as a disadvantage, I would say there is a very high cost of the installation. Nikitas will say more about the technical part, I think, in his presentation, but you can easily predict that it would be much more expensive to build an offshore wind farm comparing to onshore. So we still don't understand fully the effects on marine life and birds. And if we build it close to the coastlines, we still have some people are not happy with this, so to say. So if we are talking about the existing installation, you can see them also in the table, onshore and offshore. And the leader is Germany and Sweden. The future development means that we will have to build a big wind farms. And normally the system scale wind farm is something around 50 megawatts or higher capacity, and it means that it should be connected to a high voltage grid of 110 kilovolts or higher, because with the low voltage it will not normally work. Onshore projects for the moment have some problems and new restrictions. For example, in Poland, there's a new regulation that you cannot build a wind turbine near the buildings. There is a limit of at least 10 times turbine height. It means that we have small and smaller places which we can use for the installation. As for Germany, the biggest supplier of wind energy, the most economical feasible places are already in use. The same we could say about Denmark and partly for Sweden. But other countries still have very good potential for development of onshore installations. But I personally think, as I said before, that offshore will be more cost effective in the future and will be more popular in the future. So the current development of offshore wind power projects in the Baltic Sea you can see in the table. And if we build a trend, we will definitely see that the trends are gradual increase in wind farm installed capacity, bigger and bigger distances from the shore, and bigger installation depths. So this is easy to understand because with the development of the technologies, the size of the wind farms have increased. We have reduced risks, economy of scale, and as a result, lower construction costs per 1 kilowatt of installed capacity and levelized cost of energy. So on the other hand, if we go deeper to the sea, we will spend more money not only on the wind farm itself, but also on the connection option to the grid. And the map of existing projects you can see here. It's the development we expect till 2050. And good example of such new projects which now is under construction is so-called Kriegers Flag project. It's a Denmark project built by Danish company. And on 27th of January, they installed the first wind turbine of the project. The total capacity will be around 600 megawatts. And it's interesting that this project connects with the line, with the interconnection line, to Denmark and also Germany. They expect this wind farm to fully operate at the end of 2021. So the construction goes really fast, I would say. So as I mentioned before, it's important that the project is also an interconnection project between two countries, and it will be able, actually it's already in use, and they now can exchange up to 400 megawatts of energy between the countries using this interconnection line which we built. I personally visited this Bentwisch substation, which are now in use to take the energy from two German wind farms, offshore wind park Baltic 1 and Baltic 2. Those are my pictures. So it's a new installation and it looks like future possibilities. And what's important to mention is that the installation of new wind farms of such big capacity is issue of so-called marine spatial planning, which should allow for coexistence of different activities in the same place in marine. Those are marine transport, fishery, environments, communities, and authorities, including military areas. So with the building of this new interconnection grid, things, so to say, or lines, they also should be a subject of such marine spatial planning. So if we talk about the solar power in Baltic Sea region, it's not so bright, I would say. So this is the map of suitability range, so to say. It's not the best one in the world, so to say, but still we have some big wind farms, solar farms in Germany, in Leipzig, for example. This is 52 megawatt solar plant and 4 megawatt solar plant in Lithuania, and the idea is to build more. And those solar farms can be divided, so to say, in 3 different scales. The utility scale, which normally 10 megawatt or more, which normally connect to the local grids, supplying grids. Then we have a commercial or industrial project with the capacity of 1-2 megawatts, which is not really popular at the moment. And the third one, the residential individual projects with the capacity of 2.5 up to 20 kilowatt. And this is one of the most important, I would say, because the total development is not covered by these big power stations of 50 or 60 or 70 megawatt. The biggest part of the production with the photovoltaic panels is covered by these small individual projects which were built by the people on their own houses. And it will continue this way, I think, because in most of the countries there are some supporting mechanism. So it's interesting for the people to install such kind of installation on their roofs and even get some money from the selling the energy into the grid. But still, the big projects are also planned for the future, like 200 megawatt project in Pomerania in northern Poland and 300 megawatt project in Abenra, I think, I don't know, in Denmark. And as for Kaliningrad region, it's not really popular because we don't really have any supporting mechanism for use of solar energy at the moment. If we are talking about the big projects of 100 megawatts, it's really important to understand that the development of such projects is not possible without the upgrade of existing electrical grids of the system. We live in the area there we have 3 different systems operating at the same region. This is Nordel system, which consists Norway, Sweden, Finland, part of Denmark. This is nnshore. This is, we could say, European energy system synchronous area, and there are Russian energy systems who consist Estonia, Latvia, and Lithuania systems for the moment, but in a few years they will disconnect from Russian system and they will operate in a European system, I think. And here on the picture you can see the existing connection between the countries, which allow to operate and levelize the costs of electricity in different countries, because now the countries can exchange with the energy. And if we increase a part of renewables, which because of what they are, have some problems with the flexibility, stability, and it's not possible to control the wind energy production, as you know. So if we want to stable system, we have to build the new interconnection lines, and we have to upgrade the existing system with so-called smart technologies, which allow to operate the system in a more stable way, so to say, okay. So this is it, I think. I don't think I have more time, so I'm ready to answer the questions.
You ready? Okay. The question is, what are the advantages of a decentralized energy grid? Is this a solution for the future, or is it better to go big and centralized?
I think it's both. I mean, the decentralized grid, it only can operate if we have modern digital equipment. In this grid, we have all the parties, like the production, distribution, and consumption, which operates as the so-called agents. They're like people communicating with each other, and if there is not enough energy at the moment, the consumer should find a way to decrease its consumption. And it would not be the best option for some people, but it helps us to work like a small community, small, very small energy system. We don't have to spend a lot of energy in transmission lines as the losses, for example. It is possible, it works. We have very good examples in northern part of Russia, because it's just not possible to connect to big grid, so to say, with actually the wind turbines, solar, and it's very important to have some place where we can save energy, some batteries or other solutions, gravity system to save the energy for the moment we need. But still, it's one of the options.
Can I have last but not least question? Be very short, Andrew.
Okay.
Is there any plan in Russia to initiate renewable energy project in the Baltic Sea region in collaboration with the other countries, for instance, like German, Danish projects? Are there any ambitious plans, something like this?
No, not for the moment. We have plans to develop a wind farm in Kaliningrad, but it's we already have the small wind farm, only 5.1 megawatts. It's only 3 wind turbines, but it's new wind turbines, not the old ones. It's Enercon wind turbines, 1.7 megawatt each. So to get some experience, and we have plans to develop more and more, but for offshore installation, it's not interesting for the moment. Our interest in Russia is go to Arctic region, because in Arctic region, we have very good conditions for use of the winds. There are also some problems like with the turbine itself, because it should survive very low temperatures and so on. But this is, I think, the way where our government thinking, and we built 2, I think, facilities to build wind turbines in Russia, and there is NL company, which is partly Russian, partly, I think, maybe German. I'm not sure.
Thank you very much, Andrew. Unfortunately, yes.
Okay.
We are short, very run of time. So let me announce